I'm not tired? Yeah. Okay, here we go. So 30, 60, 90. So we wrote some very specific rules on that pink paper about a 30, 60, 90, and I want to write them again. Okay. So the first thing that I want to do is label this. When we have a 30, 60, 90 triangle, we label one side H for the hypotenuse, one side SL for the short leg, and one side LL for the long leg. We learned that if we always have the short leg, if we're always given the short leg, because that's what we want to have all the time, right? We know that the hypotenuse equals 2 times the short leg. We also know that the long leg equals the short leg times the square root of 3. Those are the two things that we know, and we can always figure that out if we're given the short leg. But as we've learned from doing special right triangles, we don't always get the short leg. Sometimes they give us the hypotenuse or the long leg, and we have to calculate all the other missing pieces. So that's where we came up with some special rules. So if I know the hypotenuse and I want to find the short leg, I know that the short leg equals the hypotenuse divided by 2. That's the first rule that I want you to remember. The second one is that the short leg equals the long leg divided by the square root of 3, or it equals the long leg times the square root of 3 over 3. And we talked about when to use the first one and when to use the second one. So I use the first one, the short leg equals the long leg divided by the square root of 3 if the measure of the long leg is like this picture right here, and it has a root of 3 attached to it. Right? If it has a root 3 attached to it, I'm going to use this formula. Why? Because those roots cancel out. Super easy. But if it doesn't have a radical attached to it, and actually if it just doesn't have the square root of 3 attached to it, don't use that. Use the other one. The only time I use the long leg divided by the square root of 3 is if it has the square root of 3 on that measure. Are we good with that? Okay, so let's do 2 examples using those 2 special rules that we just wrote up top. So the first one is really basic. I'm given a short leg. So I know that this is my short leg. This is my hypotenuse. And this is my long leg. I know that if I'm given the short leg, which I am, I know that the hypotenuse equals 2 times the short leg. So that means that my hypotenuse equals 2 times 4 root 2, which means my hypotenuse is, God bless you, 8 times the square root of 2. I also know that if I'm given the short leg, I can figure out the long leg, because the long leg equals the short leg times the square root of 3. So my long leg equals my short leg, which is 4 times the square root of 2 times the square root of 3. Remember that you can multiply the squares together, like roots together. Square roots times square roots can be multiplied together. So my long leg equals 4 times the square root of 6. Let me just leave it just like that. You don't calculate that and tell me what that decimal is. You leave it just like that. And on your test, it says leave your answer as a simplified radical. We do that for all special triangles, right? But when I look at this next example, I'm not given the short leg. Instead, I'm given the hypotenuse. So I'm going to label hypotenuse, short leg, and long leg. So I want to find the short leg. I want to use one of the equations that starts off with SL equals something. So I only know the hypotenuse. So what equation am I using? SL equals hypotenuse divided by 2. That means that my short leg equals 20 divided by 2. So what is the measure of my short leg? It's 10. Once you know the short leg, then you can find the long leg. Remember that the long leg equals the short leg times the square root of 3. So if the short leg is 10, 10 times the square root of 3 is just that, 10 times the square root of 3. So that's your long leg.
Don't you solve it?
Nope, you just leave it just like that. You leave that radical in there, okay? Are we good with that? The only time you would simplify that, Parker, is if it was a real world problem that said to the nearest tenth or to the nearest foot. If it's just a picture of a triangle like that there and there's no like word problem involved, it's not real world, you want to leave it as a simplified radical, okay? Because remember, these are special right triangles. All right, in this last example of my 30, 60, 90, what measure am I given? Given the long leg. I need to find the short leg first, and then I can easily find the hypotenuse. So I have to use one of my short leg formulas. Let's see. I know that my short leg equals, so which short leg formula do I want to use that has the long leg in it? Do I want to use the one that says the long leg divided by the square root of 3? Or do I want to use the one that says the long leg times the square root of 3 divided by 3? What do you think, Carter? The second one, why? Perfect, because the long leg doesn't have the square root of 3. So I'm going to use this formula. Long leg times the square root of 3 divided by 3. So let's see. The long leg is 12 times the square root of 3 divided by 3. What is 12 divided by 3? So my final answer is the short leg is 4 root 3. And that's perfect, because I know if my short leg is 4 root 3, my hypotenuse equals 2 times my short leg. So my hypotenuse equals 2 times 4 root 3. So my hypotenuse is 8 root 3. Okay. So I want to make sure everybody has that written down nicely, because those are going to be the ones that you like, that's going to be how you want to use it. And you know what? There's not a whole lot of room on this, and I realize that. So if you want to write on the part that you folded over and turn it into a flap this way and you flip it back, I mean, it's your binder. It's your, like, you get to use it on your test. You just put any of the information on it that you need. Does that make sense? You put on it what you need. Okay, so now I'm going to go over to the 45, 45, 90 right triangles. So we know that a 45, 45, 90 is also called an isosceles right triangle. Yeah. The word isosceles means that two of the sides are congruent. Two of the sides are congruent. And sometimes the story problem or the word problem doesn't tell you that it's a 45, 45. It uses the phrase isosceles right triangle. Heads up, you're falling asleep. That's really important. Okay, so let's talk about the rules for that. The hypotenuse equals the leg times the square root of 2. This is my hypotenuse, and this is my leg. This is also my leg. They're congruent. Okay. If I don't know the leg, I'm given the hypotenuse. I can find the leg by doing two different things. I can either take the hypotenuse and divide it by the square root of 2, or I can take the hypotenuse times the square root of 2 all over 2. When do you think I want to use the divide by the square root of 2?
When the square root of 2 is on the X.
When the hypotenuse has a square root of 2 hanging on it. Like that X value right there. Yes. Okay. So let's go label our sides and get done with these examples really fast. So right here, I have one leg that has a measure of 2 times the square root of 3. That means that the other leg also has the same measure, 2 times the square root of 3. I need to find my hypotenuse. And I know my hypotenuse is the leg times the square root of 2. So that means I have 2 square root of 3 times the square root of 2. What does that equal? It equals 2 times the square root of 6. That's what my hypotenuse is. 2 times the square root of 6. God bless you. That is my hypotenuse. In my second example, I don't know the legs. I don't know the legs. I only know the hypotenuse. So I have to use the formula that says the leg equals the hypotenuse. Am I going to do the hypotenuse divided by the square root of 2, or am I going to use the hypotenuse times the square root of 2 all over 2? The first one. Why am I going to use the first one? Because my hypotenuse measure has a square root of 2 in it. That lets me just cancel those right out. So my leg equals my hypotenuse, which is 10 root 2 divided by the square root of 2. So what is the measure of my leg? My leg equals 10. So when I look at this last example, it's another one of given a hypotenuse. It's giving me the hypotenuse, but there's no square root on it. I need to find the leg again. So I'm going to use the what, Josue? Oh, Parker, yeah. I'm going to use the second one. So the leg equals the hypotenuse times the square root of 2 divided by 2. Using that second formula. So the leg equals 4 times the square root of 2 divided by 2. Why am I doing that? Because I can do something special with that 4 and that 2. What can I do with them? Divide them. What is 4 divided by 2? So my final answer is 2 times the square root of 2. Those are the measures of my legs. Those are the measures of my legs. Okay, so open it up and we're going to do 4 word problems. 4 word problems. Okay. So a boy who is flying a kite lets out 300 feet of string, which makes an angle of 60 degrees with the ground. Assuming the string is stretched taut, find to the nearest foot how high the kite is above the ground. Sketch an image. I added a little note that says, assume the boy is holding the kite string three feet off the ground. So we have to sketch an image. I will tell you that when you guys take this test on Tuesday, you get points for doing sketches, right? And they don't have to be super elaborate, like you don't have to make stick figures or any of that stuff. But if you draw some type of triangle, you get points as long as you can label it correctly. So here's what I know. I know I've got this boy and he's got this kite string. And it says that the string is taut. And when the string is taut, it's 300 feet long. So here's his little kite, right? Kind of flying up there. So maybe it's got like a little tail on it. I don't know. But the other thing that I know is that the boy is holding the kite string 3 feet off the ground. Yeah. Okay. What is the angle of the kite string, that the angle that the kite string makes with the ground? 60 degrees. And I'm trying to figure out this. But remember, once I find that, I have to add that 3 feet back to it. So what trig function do you want to use, Olivia? What trig function do you want to use? We can label our sides if you want. Will that help you? Okay. So from this angle, what side is the hypotenuse? Oh, Olivia. Okay. What side is the opposite, Olivia? The x. Remember that the adjacent side always touches the angle. So do you see how this adjacent side is touching the angle? This side right here is touching the angle 60. So this is your adjacent side. Okay. So we're using our measures. The sides that have measures are the O and the H side. So I need to use the trig function that uses O and H. The sine. So the sine of 60 equals the opposite over the hypotenuse. What do I need to do to both sides? Multiply by 300. I'm going to multiply both sides by 300. So 300 times the sine of 60 equals x. 259.8. Plus we have to remember to add that 3 feet at the end. So about how high is the kite off the ground? So is it okay if we just say it's about 263 feet off the ground? Are you guys good with that? Feel all right about that? Okay. Let's do the one below it. Do you guys notice that this is a special right triangle? This is a 30, 60, 90. Let's see. If I think about this, this hypotenuse, I would have needed to find this is the long leg. So if I wanted to use the short leg, long leg hypotenuse type deal, I would have had to find the short leg first and then substitute it in and find the long leg. Which method do you think is easier? Using the trig function or? I agree. Okay. Hypotenuse of an isosceles right triangle. What kind of a special right triangle is that? If it's an isosceles right triangle. 45, 45, 90. So I'm going to put a 45 degree right there, my right angle here, and I'm going to mark those as congruent. The hypotenuse is 16 feet. What are the dimensions of the triangle? So I need to figure out one of the sides. What do you want to do? Yeah, your leg equals your hypotenuse times the square root of 2 divided by 2. So say that again, Luke. You said 16 times the square root of 2 divided by 2. So what is the measure of my legs? 8 square root 2. If it wanted that measurement as an actual like foot, what is that about? 8 square root 2 is about how many feet? What is 8 times the square root of 2 in your calculator? Yeah, it's about 11.3 feet. Raise your hand if you need more time. All right, this next one is about a square. Jaden, pick your head up so I know you're with me, sir. says the perimeter of a square is 64 inches. What do we know about a square? Okay, all four sides are the same. So if the perimeter equals 64 inches, what is the measure of one of the sides? How did you do that? Yeah, you guys took 64 divided by 4. I'm just writing that out for someone who didn't know. So that means that this side is 16 inches and this side is 16 inches. And it asks me to find the measurement of the diagonal to the nearest tenth. What kind of right triangle is that? Yeah, it's a 45, 45, 90. And that diagonal happens to be my hypotenuse. So if I want to find the hypotenuse, I take the leg times the square root of 2, which means that the hypotenuse is 16 times the square root of 2. But it wants that to the nearest tenth of an inch. So I have to about that in my calculator. So what's 16 times the square root of 2? Yeah, it's about 22.6 inches. I have one more, and it's going to be a rectangle. One more. It's going to be a rectangle. Are we all good? Trey, are you okay if I go on? Are you sure? Okay, because I saw you still writing. I'm sorry. Okay, so this next one, it says sketch rectangle A, B, C, D. So I'm going to just draw this rectangle and I'm going to label it A, B, C, D. So that the triangle ABC, so I have to make a triangle right here. Triangle ABC and triangle ADC are 30, 60, 90s. Well, this is the short or the small angle. This is the bigger angle. Small angle, bigger angle. And that makes sense because 30 plus 60 equals 90. So I've got that right. And it says the measure of the diagonal is 24 inches. Well, I need to figure out what the short leg is, and I need to figure out what the long leg is. That diagonal is actually equivalent to my hypotenuse. Yeah. So what's the 30, 60, 90 rule if you know the hypotenuse and you want to find the short leg? So the short leg equals the hypotenuse divided by 2, which is 24 divided by 2, which is 12 inches. Okay. So this guy is 12 inches. Okay. Was that your back that just did that? Ugh. So 12 times the square root of 3. So my long leg is 12 times the square root of 3. I want to find the perimeter and the area of the rectangle. I want to find the perimeter and the area. So let's write down some formulas. I know that the perimeter is 2 times the length plus 2 times the width. And I know that the area is just the length times the width. So let's see, my perimeter is going to be 2 times my length is my long leg, 12 times the square root of 3 plus 2 times the short leg, which is 12. What did you get for your perimeter? Ooh, I wanted perimeter. I think you gave me area, but I might be wrong. 2 times 12 times square root of 3 plus 2 times 12. Maybe I did it wrong.
I got 65.
Okay, I did it wrong. You were right. Yeah. Plus 1. What did you get again? 65 point what? I'm going to give you 1 extra credit point. 65.6 inches. When we find the area, we're going to take the length, which is the 12 square root of 3 times the width, which is 12. What do you get there? Mm, 12 times 12 is 144. 144 times 100. What did you get? 2 what? Yep, that's probably believable. 249.6.
249.41, so it's going to be equivalent to 249.4.
So 249.4 inches squared. 249.4 inches squared. Remember that area is squared. Area is squarea. So do you want me to take your mind reader thing and make it a 4 instead of a 3?
What was that?
It was that worksheet that you filled out when we